And welcome everyone to this weekly practical sequels. I don't want to sound like a DJ or something. I don't know why I'm like sounding like that. Welcome everyone. Now I'm starting to sound like I'm too serious, but I'm not. I'm just having fun. Welcome to the weekly practical SQL Server HADR show. Maybe I should start calling it a show because it's fun doing this, trying to read through people's questions and also trying to put myself in their shoes and understand what is going on with uh, the questions that they're asked. This is the Practical SQL Server HADR show, and today's focus, or this week's focus, is all about patching and maintaining HA solutions. Now, before I get into the questions, they are really interesting questions that are being asked. Um, Before I dive straight into the questions, I posted a couple of days ago about how cold it is. I'm in the capital of Canada here in Ottawa, and I posted a photo of me going out, and it was minus 25 Celsius. Today, it's beautiful. It's sunny, although you can't see it from here. It's beautiful. It's sunny, and it is minus 16 Celsius for our American friends out there. That's Fahrenheit, 3 Fahrenheit. Yeah, I just did the Celsius to Fahrenheit conversion. Sometimes I try not to. I'll just let the app do that. Although I still remember the formula for converting Fahrenheit to Celsius and back. But why would I do that? I got a phone that I could use to do the calculation for me. I'll let them worry about that. Plus, they're the only ones who use Fahrenheit in the first place. Oh yeah, we do. We do use Fahrenheit in the oven, which is kind of weird. We use Celsius for temperature, and we use Fahrenheit when we're using the oven. The good thing about this is I don't use the oven, I don't bake, and I don't cook, so I don't really care what the temperature is. And so I did post a photo the other day about how cold it is, and people were commenting about, yeah, no big deal. And somebody from the extreme colder parts of Canada were saying no big deal, while people on the warmer parts of the world are saying, come on over, we have like plus, and that for us is like summer, like plus 20 something. Yeah, that for us is summer. Some people from a couple of my friends from Portugal were saying, yeah, it's minus, no, not minus, it's plus 12 or plus 13. In some cases, that is already summer, spring to summer for us. But I'm going to enjoy the weather nevertheless because we're on lockdown. I didn't even realize we were on lockdown effective Monday last week. But it's the perks of having the opportunity to work from home. Anyway, uh, in case you don't know me, my name is Edwin Sarmiento, and I specialize in SQL Server high availability and disaster recovery, and sometimes making myself funny, which I find a much harder thing to do than dealing with SQL Server issues. Anyway, let's get started with some of the questions that were submitted throughout the week. This is the first one, and one of the reasons I wanted to focus on certain topics within the week is to get people to really think about a specific topic, a specific task. You know, SQL Server administrators or accidental DBAs or people who are taking care of SQL Server databases in general have a wide variety of tasks to perform based on their job responsibilities. And sometimes when you're all over, like, I need to do this and I need to do that and I need to do this, we don't get to see the connection between what you're doing from this part and what you're doing from this and combine them together. One of the reasons why I talk about high availability and disaster recovery, other than the fact that it is my key area of expertise, is the fact that when you start to incorporate a lot of the things that you're doing, it factors into your HA strategy, your DR strategy. So it's not just about running SQL Server agent jobs anymore. It's not just about performing database maintenance tasks anymore. It's about doing those while thinking about the effects and the side effects of it in a high availability solution, right? And that's one of the reasons why I decided I want to focus on specific topics about, about high availability and disaster recovery for that week. And this week is all about patching. Let me put that on the screen. Patching and maintaining HA solutions, because when you start to think about it, maintaining a standalone SQL Server instance or a standalone server. I mean, we're not even talking about SQL Server here, just any standalone server. It's a lot easy to maintain that versus when you're maintaining something that's highly available. Think Windows Server Failover cluster or a load balance cluster, because now you have to think about the effects of what you are doing in the high availability strategy. And more often than not, I would always go back to the things that really matter, and that is recovery point, recovery time objective, as well as service level agreement. I mean, there's a reason why you put in a high availability solution in the first place. So every time a question comes up, I always bring myself back to asking the question, what is it that really matters? And so we are going to dive into patching and maintaining high availability solutions, starting off with this question. And I also want you, as you're watching this, this is probably not your question. This is, somebody else's question. And maybe you're asking the same question to yourself. I want you to go back to the things that really matter. Ignore for a fact that you need to do this and you need the answer to this question, but I want you to focus on the thing that really matters. And that is recovery point objective, recovery time objective, and service level agreement. So let's answer this first question. Could I safely apply the CUs, meaning the cumulative updates? And we're going back SQL Server 2017 and 19 when only CUs were released, compared to SQL Server 2016 and earlier, where you have a combination of service packs and cumulative updates. So can I, or could I safely apply the CUs without, and that's the word there, without performing the failover, such as patching the secondary, suspend data movement, patch the primary, and then resume data movement. So the idea here, and I'm, Elvira is saying good evening. I don't know exactly where you are, but good evening. So the idea here is the person who asked this question wants to install the cumulative updates, maybe patch the secondary, like what he was saying, suspend the data movement, patch the primary, and then resume the data movement. It's not really a question of can you safely apply the CU, because if you look at it from the point of view of can you do it, go ahead, you can do it. But remember what I said in the beginning. Go back to the things that really matter. And that's the recovery point, recovery time objective, and service level agreement. And I'll give you a high-level overview of what the side effects of this could be. Imagine you have a 2-node failover cluster with a 2-replica availability group, okay? And I'm assuming that's what he was referring to here. Because with the failover clustered instance, let's talk about the different high availability strategies or technologies in SQL Server. You have the always-on category. I use the double quotes or the air quotes because it's becoming a marketing. It is a marketing term, mind you. It is a marketing term, and it's not a technology. Okay, so under the always-on marketing term, you have failover clustered instance, your traditional failover clustered instance, where you have 2 or more servers working together, but you only have like one SQL Server instance. Okay, the databases are in a shared storage subsystem, and you only have one copy of data. Yep, they're all on the shared storage. And I'm guessing what he meant here is, or was, an availability group where you have multiple copies of the databases, and the databases are getting synchronized, hence the pausing or suspending the data movement. Okay, so if you're simply asking me, can you do it? Yes, you can. Do whatever you want to do, but not without the side effects. And he was saying, can I safely? The question here should not even be about safely, because you can safely do that. Nobody's stopping you from doing that. Patch the secondary, reboot the secondary, patch the primary, but before you even reboot the primary, you suspend the data movement, right? Reboot it, so your AG stays on the primary, doesn't fail over, right? And as a side effect of this, your AG is going to be offline for the remainder of the time that the server is coming back while it is being rebooted, okay? The amount of time it takes to reboot the machine really depends. It depends on a couple of things. Number one, is it a VM or a physical machine? Number two, how many transaction log records need to be redone, because you're telling SQL Server to run crash recovery. It will recover all of the databases. So if you have a ton of transaction log records that need to be redone, right, that will factor into how long the databases would come up on that same machine. And is it a physical machine? And I remember the days of the IBM series where you have daisy chain servers where a reboot would take 40 minutes. And I'm not kidding, 40 minutes. So that is something that you would have to consider. That's why I said, if the question simply warrants a yes or no answer, yes, you can safely apply the CU without performing the failover. But is that really the question you want to ask? Because the question that you need to be asking is, if I do this, can I still meet my recovery point objective, my recovery time objective, and my service level agreement? Because here's the thing. Here's the thing. Let's say, because the reason why you put your databases in an availability group or in any high availability solution is you want to achieve high availability, and you have numbers. That's why I keep emphasizing on recovery point, recovery time, and service level agreements. You have those goals to achieve. And if you can't meet those goals, then you're in trouble. Okay? There's a reason why people talk about 5 nines, 4 nines. So imagine if it would take, I'm just saying, it takes 12 minutes to reboot your primary, and your recovery time objective, meaning the amount of time it takes for you to fail over or to bring the databases back online, is 2 minutes. You already broke your recovery time objective just by doing this. Okay? Again, I'm giving you some guidelines here on whether or not you can do it, because it's easy to come up with a strategy to be able to do it. Like he actually described the way he wanted to do it. Patch the secondary, suspend the data movement on the primary, patch the primary, and then resume the data movement. Yeah, it is very easy to accomplish what he wanted to do. But the question is, did it meet the overall goal? And the overall goal is to meet your recovery point objective, your recovery time objective, and service level agreement. I kind of emphasize this a lot whenever I deal with customers deploying HA solutions, because sometimes they would just suggest, or they would just ask me to build some complex thing, whether it's an 8 replica AG spread across multiple data centers, and they would ask questions, hey, can this be done? They're forgetting the one thing that they need to ask. What are we trying to achieve here? Are we trying to build an AG? Are we trying to build a complex architecture? Or is it to meet a certain high availability requirement? And that should dictate everything that you need to do, including installing service packs, cumulative updates, or even performing Windows updates. So I know I've talked a lot about this, because it's not enough to simply ask the how do I do questions, or how do you do, or the tutorial time question, because that's easy, right? I can tell you exactly what you need to do, but if it's not going to meet your goals, then it's useless, right? I remember I use analogies a lot, and I remember somebody once told me, it doesn't matter if I give you a Ferrari, if you don't know how to drive, then you're going to crash and burn. It's the best car that you could have, but if you don't know how to drive, you're going to crash and burn, right? So that is the kind of like the response that I would give whenever somebody asks me the question. This is the second one. What's the best way to temporarily take asynchronous AG offline to allow maintenance and patching, etc.? So I'm again, I'm assuming this is a I'll just use a very simple architecture with a 2-node failover cluster with a 2 replica AG. What is the best way to temporarily take asynchronous AG offline? Asking the best way is a very slippery slope, because when you start asking for the best way, you start to take that as gospel truth. It's one of the reasons why I don't really recommend best practices, because when somebody recommends best practice, like for instance, VMware's best practice on how to install SQL Server on a VMware architecture, or Microsoft's best practices on deploying SQL Server always on availability group and the number of databases, there always is a best practice. The way I look at this is, well, their budget is not your budget. Their skill set is not your skill set. Their manpower is not your manpower. And I remember talking to a client a couple of years ago where they built a 3-node failover cluster with a 3-replica AG, 2 of which are in production and 1 of which is in DR. And I asked him, so why did you build this? And he said, well, it's in the Microsoft documentation. This is the best practice architecture for us. And so what are the typical issues that you get? Well, I find that now I'm getting burned out because everybody's calling me for this. I'm like, okay, you just built something that would throw you off, that would put you in survival mode because you're the only person who knows about this, right? So even asking this question, what's the best way to temporarily take the synchronous AG offline to allow maintenance and patching? The best way is the one that works for you. I'll give an example here. If you're the only person on the team doing this, you're in full control of what is going on, assuming, of course, that you know exactly the side effects and the impacts of taking asynchronous AG offline to allow maintenance. For instance, again, a 2-node failover cluster with a 2-replica AG, automatic failover in synchronous commit. You take the synchronous AG offline however you want to take it offline. So let's say you reboot the machine, you start the SQL Server service. What's going to happen with automatic failover and synchronous commit? Assuming that the secondary is failover ready and the cluster has quorum, the failover will happen. Is that the best way? Well, if you're the only person on the team, that's the only way that you can deal with this. Because what happens if, let's say, you are, there's the Windows team and the SQL Server team in large enterprises, right? If the Windows team is performing maintenance on the underlying operating system or on the server, that is, are they really aware that there is a synchronous commit automatic failover availability group running on top of the failover cluster? I doubt, unless they have a documentation in place and a proper change management process that explains this is how we perform maintenance. Okay, this is again one of the reasons why there really is no best way other than the one that works for you. Okay, so again, people are saying, well, wait a second, I'm asking these questions and I want a straight answer and you're not giving me, because the reality is this: in large organizations where you have segregation of duties, the Windows team is responsible for taking care of the Windows Server operating system. They're the one responsible for the failover cluster. Do they know that it is an AG? It's a SQL Server availability group running on top of that cluster. All they know is that they see this resource group or role in the failover cluster, and they think, oh, it's just like all the other failover cluster resources that I've done in the past. Let me move it. Let me move it. Ooh, it's not. Ooh, it's not. Ooh, it's not. And when you are in that state, the AG would be taken offline for a long period of time. The sysadmins don't know what they're doing, and guess who gets the blame? You are. Why? Because you're a DBA. You're the one responsible for the databases. And the irony behind this is you're getting blamed for something that you didn't do. Oh, and by the way, you also get to be the one to fix it. And that's just the reality of this. And that's why when people start asking about the best way, they're not asking about who do I need to work with as far as this task is concerned. Is it just me? Is it me and the Windows team? Is it me and the security team? Or is it just them? Because when they're performing maintenance on the Windows Server operating system, they may not be aware of what is going on under the covers. They may not be aware of the fact that it is an availability group and there is a proper way of doing this. I remember a client of mine from way back when. They were installing SQL. Yeah, the SQL Server 2014. They're running SQL Server 2014 back then, and they were installing patches on a Windows machine, the underlying cluster that the availability group is running on. And this is the Windows team, right? This is the Windows team doing this. The DBA team were not aware that the Windows team needs to perform maintenance. Installed patches on the secondary, which is the guideline. Rule of thumb, you start off with your standby or your secondary, install the patch, and guess what most of us do when we install the patches? We reboot the machine. That way it's clean, no need for pending reboot that any of the other applications would experience. And so they rebooted it. Guess what happened next? Yeah, they lost their AG. Because the sysadmins are not aware that the witness, and it's part of their infrastructure, is like they have a 2-node Windows Server failover cluster with a file share witness. They were not aware that their file share witness is not working properly. There were some network issues that is preventing the file share witness from participating in a cluster on a consistent basis. And there were a ton of events in the Windows event log, but they were not aware of that. All they knew was that, hey, the cluster would work. Besides, this is standby, I would reboot it. And it took the entire AG offline. It wasn't the DBA's fault. It wasn't SQL Server's fault. It was the cluster's fault. But then they thought this is the best way to do it. Install this patches on the secondary, reboot, and we'll just think that it would do what it's supposed to do. Unfortunately, it didn't. And I told them that's by design. And they were not happy with it. Because again, the idea is you may think this is how it's been done all the while because that's how you've done it before. But without understanding the inner workings of the infrastructure, like availability group sitting on top of a failover cluster, then that could spell the difference between an outage that would last for hours and something that would just take like a 5-minute reboot. Okay, so yes, the best way is the one that actually works for you, and don't just think of it as the technology, but think of it as a combination of, I call it the PPT manifesto. The people. Are you including the Windows team? Is it just you? Because keep in mind, even if you're just installing SQL Server patches or even just Windows patches, your availability groups are at risk of going offline if the person who's doing the maintenance does not know what they're doing or not aware. Okay, because they know exactly what they're doing. They're just not aware of the side effects of what they're doing. Okay, and then the process. What is the process? Whether it's installing Windows patches or SQL Server patches, right? And technology being your failover cluster and the availability group, okay? Third question. This is kind of like a repeat of some of these. Do we need to apply patch for all servers at the same time, or can we delay the installation of the other replicas? And yeah, I'm guessing this may have something to do with the amount of time it takes to perform maintenance. So sometimes when you're installing patches, service packs, cumulative updates, it would take longer, right? With cumulative updates, not so much, but with service packs, it does take a lot longer sometimes. Especially if you have a really complex architecture. For instance, you have a multi-node failover clustered instance and you have multi-instance running. And you want to patch all of them, right? That's a administrative nightmare. Imagine a 4-node Windows Server failover cluster with a 4-instance, with 4 SQL Server failover clustered instance on top of that. Okay, because you got to do it. You have to do it on every single one of them. So that's 4 by 4. That's 16 times. Just think about that for a second. So, do we need to apply patch for all the servers? The recommendation is you have to. Okay, you have to do it because the way I look at it is this: whether you're installing a service pack or a cumulative update, that is an upgrade. As far as I'm concerned, that is an upgrade. The behavior of the database engine might be consistent throughout cumulative updates. For instance, the incremental changes in the database engine might be, I would say, negligible, but of course, that should be factored into your testing environment. And what I mean by that is you have to see how your applications behave when you install the patch. I'm assuming you're testing it in a safe environment, like your staging environment, and then having your applications do their smoke testing and functionality testing, right? So that's something that you have to put into your change management process. So when you're updating a secondary, assume that it is an upgrade, because technically it is an upgrade. You see the version numbers increase. The patches are incrementing the version numbers. Might not be the major version, could be the minor version, but still the idea with that is it is an upgrade. And so when you're doing a database upgrade and then you fail over to that secondary that is now becoming your new primary, how sure are you that it is not going to fail back? Right? So now your new primary has a higher version of SQL Server than your old primary. So what are the odds? What are the chances that your AG or your failover clustered instance is not going to fail over back to it? And just like how you cannot restore a backup from a higher version to a lower version, your AG or your FCI is not going to be able to fail over back to the old primary because it has a lower version. Now, again, depending on what you install, because I've tested on some cumulative updates, it works, but that's not the general behavior. That's why you still have to test it prior to pushing it in production. That's where the proper change management process comes in. So in addition to making sure that you have all of your servers patches, because that's going to be a management nightmare, especially when you're doing audits. Security audits would come in and say, hey, how come this version is different from this? And you want it to be stable, highly available, reliable, right? That is the goal. And the fact that you are not running the same version numbers of SQL Server. Sometimes Windows, I don't really pay attention much to. I say that as a Windows admin back in the days. But I pay more attention to the SQL Server version numbers because your applications are going to behave differently if not tested with the new cumulative updates and service packs. Kent was saying, I guess I can say we handled this problem in two ways. Typically, the SQL Server DBAs had complete control of the SQL Server clusters, and when patching was required, a DBA had to be available. Yes, that is a people and a process thing. That is a people and a process thing. I can't count the number of times when a DBA got blamed when an AG or a failover clustered instance went offline because a sysadmin performed maintenance on the secondary thinking it's just a secondary. Nothing's going to happen. Okay. Yes. And again, just wanted to highlight, and very good, really great comment there, because that's a people and a process thing, not a technology thing. So when people are asking, hey, can I do this? Yeah, you can do it, but you have to keep into consideration or take into consideration the people and the process aspect of it. Okay. Now going back to the main question here, do we need to apply patch for all servers? Yes. If you want to keep yourself sane, if you want to follow best practices as far as keeping everything consistent. At the end of the day, any high availability solution should look exactly the same. A failover cluster has to have every single node and every single app running on top of it to be the exact same thing, right? Because from the point of view of the application, there is no many servers. There's just one. And so the application should expect that the behavior of one replica should be the behavior of all of the replicas, and not having them all in the same patch level defeats that purpose. Okay. All right. Where are we? I think this is this is the third question. Man. Fourth question. Really? Is it the fourth? 1, 2, 3. Yeah, it is the fourth question. So what do you think about skipping CUs instead of installing every release? This is a really interesting question, especially when Microsoft started releasing cumulative updates rather than service packs. Because back in the days, I feel weird saying back in the days because I feel like I'm too old. Because I am. Back in previous versions, there you go, service packs were released not as frequent as cumulative updates. And so people would install service packs. They have more time to test it. They have more time to uh, check for consistencies with applications. Although I'm saying this assuming that we all do that, the reality is we don't. We don't. We just install patches and cross our fingers that nothing happens. I remember the good old days, and again, I'm sounding like an old guy here. I remember the good old days of patching a SQL Server 2000 failover cluster, where you install the patch on the primary node and let it rip across all of the cluster nodes. Meaning, if something went wrong, I am going to be working on overtime for the next 24 to 48 hours. Yes, and I've had one of those in the SQL Server 2005 days. But the thing is, Microsoft has improved the way you install patches and cumulative updates for high availability solutions, where you can now start off with your secondary, so that if something goes wrong with your secondary, you can pause that, but not cause severe outages on your primary. And whether you're running a failover clustered instance or an availability group, it's still safe to do so. Okay. Kenneth was saying Microsoft claims CUs are at the same level of stability as the former service pack. Does this match your experience? Here's the thing. My experience is anecdotal. And the reason I say this is because I've had cases, especially when I was writing my book, The SQL Server DBA's Guide to Docker Containers. One of the things that I did extensively was install cumulative updates. This was SQL Server 2017 and SQL Server 2019. And I was testing installing cumulative updates and rolling them back, because I treat service packs and cumulative updates installation as an upgrade project. And when I mean upgrade project, I have a change management process in place. I have a project plan in place. But the reality is we don't treat them like that. We treat cumulative updates as if it's an ordinary Windows patch. Like, I'm not talking about server. Your typical Windows 10. Or even worse, we treat it like an update on your phone. You click update and that's it. Right? We don't think about testing until your applications start to break. I got bitten by this years ago in the SQL Server 2005 days, where we installed a .NET Framework patch. .NET Framework does not have anything to do with SQL Server, but SQL Server 2005 ran on top of .NET Framework, or was a byproduct of the .NET Framework. It worked well in UAT, worked well on staging, so we're good. And we had a proper rollback plan. Like, we took database backups and all of that. When it came to production, all hell broke loose, and it took 4 hours for us to recover all of the databases. Mind you, this is a standalone instance. We're not looking at a high availability solution like a failover clustered instance or database mirroring back then. But this was tested in UAT and staging. And we were not expecting that it would go sideways on the production environment. And that's why I'm very careful. Yes, Kenneth was saying, I vividly remember FIPS. Yes, those were the days. And this is one of the things why I said my experience is anecdotal, because my environment does not look exactly like yours. And that's one of the reasons why you need to have a staging environment, or an environment that's not exactly your production, but looks exactly, or it mimics your production environment, not your development environment, because when you mess around with that, your developers are going to hate you for it. But the idea of having a safe environment that looks exactly like production, and this is where change management process really plays a big role. You apply the changes on your production the same way you apply changes on the staging environment. That way, they look exactly the same. And when you're installing patches, the one thing that Microsoft would tell you is that the minute that a CU is released, and they even have it as a best practice, and that goes back to the question I answered earlier, is that Microsoft's best practice might not necessarily work for you. Why? Because you don't have their manpower. You don't have their skill set. You don't have the resources. And so you may end up in a situation where you may have to skip cumulative updates. Not because you don't trust the way Microsoft does it, it's just because you don't have enough resources for it. Because every time you're installing cumulative updates, and let's take a look at SQL Server 2019 for a second. There's 14 cumulative updates released ever since RTM. Yeah, 14. Do you have enough cycles in a month to install, test, validate, smoke test, functionality test? And that's just on staging, by the way, before you promote it to production. Do you have that kind of resource? And that's why you may end up skipping CUs. Now, of course, if it's a 0-day exploit that you need to patch immediately, then go ahead. But you still have to do the testing, because the last thing you want is to install a critical update that ends up taking your entire high availability solution offline. And now you're in a much worse position than you were before you installed the patch. Okay, that's why this has to be treated like an upgrade project. Seriously though, if we didn't have the backups, if we didn't have the rollback plan for the production environment before we install the patch, we would have to rebuild everything from scratch, and it would take hours, which would blow up our recovery point, recovery time, objective, and service level agreement. And that's why I keep emphasizing in the beginning, go back to the things that really matter: the recovery point, recovery time, and objective and service level agreement. So yes, what do I think about this? It all depends on whether you have the resources, because this is not the only thing that you're going to be doing every day. You are going to do other things as well. And the last thing we want is to introduce inconsistencies or changes in our environment that would make it unreliable and unstable. In fact, the way I tell sysadmins and DBAs taking care of high availability solutions, if you're making modifications to your failover cluster, to your AG on a regular basis, there's something wrong with your process, because you want to keep it as stable, as reliable, right, and as resilient as you possibly can. And the more changes you're introducing, the more you're violating that. It's the law of entropy, if you could think of it that way. Okay, so this is, I think, the fifth question. Wow. How do you deal with installing Windows updates on a failover cluster running an AG? I think I've answered this question in one of the previous questions. How do I deal with it? The same way I would deal with installing patches with SQL Server with AG. But it's really not about the installing Windows, installing SQL Server patches. There are cases when the Windows patches are released in totally different date than that of the SQL Server. Sometimes there's a 0-day exploit Microsoft needs to roll out, and it came out on Wednesday. You need to install that immediately, and then next week Microsoft released a cumulative update for SQL Server, and you have to schedule that. And the one thing that is very difficult to get is approval from the stakeholders, right? It's the approval from the stakeholders. People are responsible for this, because you need to have a proper change management plan. And I'm emphasizing this because it involves people. If you're running a mission critical database on an AG or an FCI and you're running it on a failover cluster, somebody has to approve the maintenance window. The business stakeholders need to approve the maintenance window. And the question that you need to ask yourself is, how easy is it to ask for approval? But we don't think about that. We think about, oh, I need to switch the failover mode from automatic to manual, install it. We think about the things that we need to do, not about the things that we need to do prior to doing the things that we need to do. And I've had cases where it took months to even get approval for a multi-AG deployment. So this is a 4-node Windows Server failover cluster with a 4 AG. deployment. Every single node has its own AG as a primary replica, and asking for approval, just for the approval of performing maintenance on every single node and every single AG took months. And so when you start to think about combining both Windows and SQL Server patches, it is a challenge to even get both installed at the same time. I mean, talking about Windows and SQL Server, right? In addition to that, how do I deal with this? I educate my Windows guys about the impacts of what they're doing in the availability group. One of the things that you would see from the Microsoft documentation is, oh, by the way, it's another question that comes up. So I'll leave that off and answer it later. But one of the things that you will see in the Microsoft documentation is to switch to failover mode from automatic to manual. Okay. Your Windows sysadmins, because we're talking about Windows updates here, your Windows sysadmins would do that the way they've done it in the past. And that is, they go open failover cluster manager, go to the clustered resource, and then remove the node from the list of possible owners. That's not the way to do it, because there will be inconsistencies between what the failover cluster sees and what the availability group knows. So from the point of view of the availability group, well, this is still an automatic failover, so I will do whatever I can to initiate automatic failover in case something goes wrong. But the failover cluster now thinks, hey, this is no longer an automatic failover. So there's inconsistency between what the cluster sees and what SQL Server knows. But that's how they've done it in the past. And so they will keep doing it until you include it in your change management process. This is how we do it. And you might be wondering, wait a second, he's talking about Windows updates. Yes, but the fact still remains, your availability groups sit on top of a failover cluster. So even if they're simply installing service packs or cumulative updates or whatever, security updates for Windows, it will affect how your AGs behave. I heard one sysadmin who tried to move, okay, he tried to move the availability group from failover cluster manager using how he did it before. Right click, move to, and then select the best possible node. And he was surprised. Hey, how come I couldn't fail it over? I couldn't move it to the secondary replica. I'm supposed to do it. And he's not aware of the fact that in order for failover to occur, whether it's manual or automatic failover, there are certain conditions. And one of those conditions is that all of the databases in the AG need to be failover ready. Even if you have like 25 databases that are all failover ready and just one database is not failover ready, then the AG is not going to move. And he's doing it from inside the Windows Server failover cluster. And so when people are not aware of what is going on, they start to panic. And this is a production environment, right? This is a production environment. It becomes a nerve-wracking experience when you're doing something in production and what you thought should work didn't work. And that's one of the reasons why you have to coordinate this with your Windows guys. And Kenneth mentioned something earlier where they resolve that by having the DBAs take care of the failover clusters, meaning from the Windows side of things down to the AG side of things. There are organizations where you can't do that because of segregation of duties, and the security guy would dictate, no, this is not how you do it. And so you have to properly educate your sysadmins, your Windows administrators, on how to properly do it. And people were asking me back in the days, shouldn't we just give the Windows sysadmins privileges so that they can open SQL Server Management Studio and then do the failover, failback from there instead of failover? You don't want to do that. You don't want to give a 5-year-old the keys to your most expensive car. Although I read a news the other day about a kid who actually went somewhere, drove the car so he can get a gift for his little sister, I think. But again, it's one of those things where you really have to where you really have to be cautious about this. And this is a team effort. It is not just a technology thing, it's a process thing and a people thing as well. So you have to consider all of these, right? The last question I have in the queue is a continuation of what I just mentioned. Why is it important to set the failover mode to manual before patching? And this applies to both failover clustered instance and availability groups as well. Okay, the failover mode dictates how the cluster decides to move the resource group, and I'm talking general terms when it comes to the failover cluster. The failover mode decides how the failover cluster will move the resource around. Okay, automatic failover means that the cluster has full control of moving the resources around, the clustered resources around. Okay, if something goes wrong with the primary, the cluster decides, hey, I want to move this resource group from this machine to that machine. Okay, this translates into the list of possible owners from inside a failover cluster. This is how the cluster knows whether to move it to node 2 or node 3 by looking at the list of possible owners. Now, the question is, why is it important to set the failover mode to manual? We want to prevent the failover cluster to move the resource group to this node while you're doing the patching. Why is that? Let's say you're installing patches, cumulative updates on node 2 or server 2, and then out of nowhere, right, you see this progress bar on your installation. While you're right in the middle of it, something went wrong on your primary and it triggered a failover. If this node is in the list of possible owners, meaning from the AG point of view, if automatic failover is configured for this node or for this replica, the failover cluster has no other choice but to failover to this node. Okay? Of course, that only matters if you have more than 2 nodes. Because if you have 3 nodes, while the cluster will not failover to this node, it will failover to the other node configured for automatic failover, right? And that's the reason why it is important to set the failover mode to manual to prevent the failover cluster from moving that resource, that cluster resource, aka the availability group in this case, to move that resource from node 1 to the node that you're currently patching. Because it's not going to work, right? You failover, this thing is offline, it's not going to work, right? The cluster can then proceed to fail over to the other nodes that are not being patched at the moment. It's also one of the reasons why you don't patch all nodes at the same time. You wait. If you have a 3-node failover cluster with 3 replica AG, patch node 3 first, reboot it, finish it. Then you move on to node 2 or replica 2. Patch it, reboot it, wait. And that's the only time that you patch node 1, replica 1. Okay? There's a proper process in place. There's a proper way of doing it, and make sure that, and I'm talking about the Windows cluster nodes here, your Windows sysadmins know that. Unfortunately, though, like I mentioned in the previous question, the way they know how to do it is to go into the clustered resource in Failover Cluster Manager and uncheck that node from the list of possible owners. That's not the way to do it when you have an AG. If you have a failover clustered instance, sure, go ahead, do exactly what you've done in the past. But with an availability group, you have to do it from inside SQL Server, because SQL Server is the one that is going to talk to the failover cluster to remove that node from the list of possible owners. Having that process in place guarantee check. Mike, 1, 2, 3, check. Hopefully. All right, there you go. And that is one of the reasons why you need to have a change management process in place. And you've probably heard me say that a couple of times now. Have a change management process in place for patching both Windows and SQL Server that everybody on the team can rely on. You know, it's interesting when you take your car to a mechanic, whether it's the guy who's been working there for 5 years or the newly hired guy, it's interesting that they know exactly what to do. Why? They have a checklist. They have a checklist. And whoever's responsible for some portions of the car will take care of that portion. The guy who's in charge of the electronics, he will take care of the electronics. The guy in charge of the engine, he'll take care of the engine. The guy in charge of the structure, he will take care of that. But more often than not, when we're patching Windows and we're patching SQL Server, we are kind of saying sound. I hope you can hear me because let me see. Audio. Yes. Yeah, my audio is still there. Um, it's interesting when we see how high availability solutions like availability groups and failover clustered instances. And with database mirroring, it's not really much of a big deal because it's the DBA typically in charge of the database mirroring session. But it's interesting how we just let the Windows guys take care of the failover cluster without them understanding the impacts of what they're doing inside the availability group. It's interesting how we would let the VM guys, VMware guys, the Hyper-V guys, take care of performing maintenance on the VMs without knowing the impacts of what they're doing on the failover cluster, on the AG, on the failover clustered instance. There are a couple of horror stories that I could tell about the VM guys taking snapshots as a backup. Yes, their failover cluster is running on VMware or Hyper-V, where they have availability groups. The nodes and replicas are on different servers. But when they do take a snapshot of the entire VM as a backup, and they don't know that this takes the entire thing offline because the snapshot would take like 45 seconds, like 25 seconds and higher. They're not aware of the fact that the heartbeat settings for the failover cluster does not take into account the amount of time that it would not be able to communicate with the other nodes in the failover cluster. It's interesting that we are allowing people who are not aware of what is going on with the failover cluster, with the AG, to do maintenance. And then when something goes wrong, they're going to call you, the DBA. They're going to bug you. Oh, before even. They're going to blame you because you didn't keep the databases up and running. You didn't keep the databases highly available. You're getting blamed for something you didn't do, and you're being asked to fix a problem that you didn't cause. Okay, and this keeps happening, right? It keeps happening. So you owe it to yourself. You owe it to your sanity and your health to make your sysadmins aware, make your VM guys aware if you're running your failover clusters on a VM, to make them aware of the side effects of what is going on if they're performing maintenance on the Windows machine, on the VM, on the hardware, because sometimes they would perform hardware maintenance, like for instance, a broken network adapter, right? Some hardware guys would just power down the machine, especially if it's just a secondary. They would power down the machine thinking, hey, no big deal, right? Without realizing there's an AG running on top of it, there's a failover cluster running on top of it. And so the longer that they take the time to fix the hardware, the higher the risk that you're introducing to your databases, because you're growing your transactional log file. There's a ton of transaction log records that have not been replicated over to your secondary replica. And so they're not aware of that. All they know is that we ask for a maintenance window. We ask for a maintenance window. We need to fix a network adapter. We need to fix a broken board or a broken PCI slot. We need to fix that, but they're not aware of the risk. And so it is your job as a SQL Server DBA to be aware of when somebody else is performing maintenance. And it doesn't have to be SQL Server maintenance. It could be hardware maintenance, it could be operating system maintenance, but you have to be aware. Okay, it is your responsibility. You may have to take that replica out of the AG until the hardware guys are finished with performing the maintenance. And like I said, I want to wrap this up. I want to wrap this up with just emphasizing the fact that when you are dealing with high availability solutions running SQL Server, you have to make sure that you're not just focusing on the technology. You're not just focusing on, yeah, this is what I need to do, because your SQL Server databases are now dependent on the things that you're not even aware are dependent on. And so if somebody else is performing maintenance on something and you're dependent on that, then you have to know, because you're going to get blamed when your databases cannot, come back online. And I'll wrap this up with a story that I had from way back when. And I learned this the hard way. I was performing patches and maintenance on okay, I'm old. SQL Server 2000, failover cluster running on Windows Server 2003. Yes, that old. This was about 15 years ago. And we have a proper change management process, and I was installing Windows patches. Mind you, Windows patches on the standby node. Okay, well and good. Rebooted the standby node, and I'm ready. Because this was SQL Server 2000, and there's no big deal for me to fail over, I installed the Windows patches on the primary node and then waited until everything is okay before I failed over the failover clustered instance to my secondary node. I don't want to call it active and passive. It's going to throw a massive debate about the terms. But anyway, I waited until everything's up and running before I decided to reboot the primary node. 5 minutes later, I get an email alert from our monitoring system telling me your failover cluster is done offline. And I'm talking about the SQL Server failover clustered instance. The SQL Server failover clustered instance is offline. I'm like, what? I did exactly what I needed to do. So what is going on? It's interesting, the old management console. I don't miss the old Microsoft management consoles for failover cluster. Went in there, and I tried to bring the failover clustered instance online. I couldn't. I mean, come on. My nodes are both up and running, right? The primary and the secondary node are both up and running. There is no problem with that. My failover cluster is healthy, but I could not bring the failover clustered instance online. Turns out one of the operations engineers accidentally rebooted all of the domain controllers at the same time. Yes, on average, it took about 20 minutes to reboot a machine. So that's a span of 20 minutes rebooting all domain controllers. And we had like 3 domain controllers in the environment. 3. They are not aware that you're not supposed to reboot all domain controllers at the same time. They're not aware. But, and here's what I'm trying to point out. Your SQL Server virtual network name, in the case of a failover clustered instance, your SQL Server availability group listener name, they're both Active Directory computer objects. When you're failing over, part of that is checking the domain controller because it needs to authenticate before it can come online on the secondary node. And of course, Microsoft has fixed that with a bunch of credential caching on the primary and the secondary nodes. But the thing still remains. Your failover cluster virtual network name, as well as your availability group listener name, are Active Directory computer objects. So if there is no Active Directory domain controller to authenticate, then there's no way to bring them online on the secondary node. And Even today, when somebody says, hey, I cannot bring my AG, my listener is not coming online, well, that's a DNS record. That's an Active Directory computer object. And if you can't bring it online, even if you try and force it, well, there's something wrong with Active Directory. And you're now at the mercy of your Active Directory guys. And I'll wrap this up because we're less than a minute in before the end of the session. Make sure that anytime somebody performs maintenance across your network that would affect your availability groups or your failover clustered instances, you become aware and create a change management process that would allow them to properly do the maintenance, okay, in order to minimize downtime, because that's the ultimate goal. Okay, you want to provide high availability to your databases, but not to allow the not allow other people's not being informed to inflict, I don't want to say inflict pain and suffering, because that's exactly what's going to happen. You're going to get blamed for something you didn't do, but you're going to get called in to fix something that somebody else breaks, and that's just reality. And we want to prevent that from happening. Prevent, mitigate, because we're all about risk mitigation. Anyway, tune in again for the next week's session of our Practical SQL Server HADR show. I'm starting to call it a show. And if you're watching this as a recording on either LinkedIn or YouTube, I've put a link in those recordings or in the bottom of this, so you can submit your questions way ahead of time, and I will answer them during these sessions. Tune in again next week for another Ask Me Anything question on SQL Server high availability and disaster recovery. And enjoy the rest of your weekend, wherever you guys are. Enjoy the rest of your weekend. I'll see you again next week.